Welcome back to our studio practice. In today's demonstrations, I would like to share with you how to fake a simple light beam effect within Maya environment. The ingredient to this emissive light effect is pretty simple. It's all about crafting a color map that has an alpha channel in it, then map it onto a polygon mesh. And here is the demonstrations of the method. First, let's create a pipe mesh that are custom to our needs. Next, let's switch to the isolate view and make sure the backface culling is working. Now we are going to delete these bottom faces as it would not be needed. Next, let's try to soften normal of the edges here. In the next few working steps, I'm going to optimize the pipe mesh into a modular state so that we can unwrap and overlay the UVs easily. To speed up the unwrapping process, do try to make a good use of automatic mapping approach. Next, we will need to solve and move the UVs as one, then place it at a corner of our layout. During the process of laying out your UVs, do plan and make a good use of the spacing. Pack as much as possible. It would be a good idea to turn on the UV's shaded display when working in the UV editor. Next, we are going to reconstruct the pipe mesh back to its original state. Remember to merge the vertices after combining these two polygonal mesh. As you can see from the UV editor, Any overlap UVs will be displayed with different shaded color. Occasionally, do check out the merge vertices. Make sure they are all welded properly. Next, we are going to snapshot our UVs and bring it into Photoshop. First, we will need to ditch the default alpha channel. Then, we are going to cluster our layers before creating an emissive color map. Now, create a layer and rename it. First of all, let's make a marquee selections around our UVs. Then, activating your brush paint tool. In the swatches, simply pick a range of warm and cold color, and do paint it within the area of the marquee selections. After that, we are going to blend all these colors with the Gaussian blur filter. Do apply the transform tool and scale the layer upward for covering the area of the UVs. Do it where you see fit. Next, apply the marquee selection again. Go to Filter and activate the distortion filter of wave. Feel free to play around with its setting. The use of this filter is intended to emulate a simulated light wave. Alright, in the next few steps, we are going to create a simple alpha map based on this colored layer. An alpha map has to be a grayscale image. which define between the binary rate of 0 and 1, or simply representing the color of black and white in our context. You can increase the contrast of the alpha by adjusting its level. You can turn the simulated wave beam into a more synchronized wavelength. Alternately, you can make use of the curve tool for having a finer control over the level of contrast. To enhance the intensity of the gradient, you can consider to stack up the duplicated layer with different opacity value. The idea of the alpha channel here is to emulate the fall-off of a light beam when it reaches a certain distance. And we can enhance this sort of decay rate with an extra layer mask. You can specify the fall-off distance within a gradient field too. Okay, next we are going to consolidate these grayscale layers and copy it as the alpha channel. Next, we are about to save out the map, but beforehand, let's hide this UV layer away. And set the background layer into the color of black. During the process of saving the map, do make sure the alpha channels is checked on while layers options is ticked off. and we do not need to compress our emissive map at this point of time. Now, let's jump back to Maya. First of all, let's clear the history of the pipe mesh and rename it via the channel box. Next, do assign a new material for it. Then, link the color slot with the color map, which we had created earlier. As you can see, the opacity of the pipe mesh has begun to look transparent as it reaches upward. Let's increase the ambient colors value and switch our viewport to the high quality display. Do try to set the viewport to 2.0 display system if your graphic card can support it. This would give us a better real-time preview for the effect that we are trying to emulate. Now let's try to alter the mesh by grabbing these vertices and scale it widely for better emulating the effect of a diffuse light beam. I have noticed that the polygon mesh has some normal issue, which created the illusions of broken seam. These can be corrected by applying the soften edge functions. But for this undesirable black line is most likely caused by the texture itself, as it was not tolerable in the first place. It has to be fixed via Photoshop later. Next, let's change our right viewport to render view and set the render system to hardware render. The hardware renderer is used to output a render still image that is closer to our viewport display with an alpha channel. Hardware rendering is a fast and low-cost renderer that riding on top of the GPU. However, it has quite a number of limitations. Try to hit the render button now. You should be able to see an image being rendered out almost instantly. Now let's switch our renderer to software render. Do change its render settings to the production quality and then hit render again. You will notice the render speed is a bit lag behind if compared to the previous hardware renderer, as it was generated by the CPU that shared with other applications. Go to the shaders interface and let's adjust a higher value for the ambient color again. You will notice that your perspective viewport will give you an immediate feedback. Okay, let's try to render with hardware renderer. You will notice the outcome is more desirable. However, in Maya, there is an emissive effect that known as a glow, which only favors software renderer. In the shaders interface, look for a context menu of a special effects. Set glow intensity to a number. Then do a render test. You should be able to see an intensive glow effect. Now, try this. Go back to the shader interface and check on the hide source options. You get a hollow glow effect instead. Do try to set it to a different value for the intensity. As you can see, the higher the number, the more it glows. Now let's switch our render system back to hardware mode with a test render. And you wonder where is the glow effect has gone. The glow effect that we have seen just now is meant for software-based rendering and not real-time. This is largely got to do with Maya's default limitations with its shaders and viewport render system. Anyhow, the message here is that in game texturing, do not rely on software-generated previews or renders. You must always strive to texture for hardware rendering mode. As long as the texture entity looks perfectly good in the viewport, it is usually fine looking in game engine. So to achieve a simple outlook of this tutorial, it's all about spending time for fine-tuning your texture in Photoshop. If you wish to learn more about real-time glow effect, I recommend you to read more about it in GPU Gems. It is a classic literature in 3D rendering. Thank you.